Welcome. This is Coach Dorf. Now we're going to talk about inverse trig functions. Remember from last time, we mentioned that inverse functions allow us to undo what original functions do, and this allows us to solve more complicated problems. We have been talking about trig functions, and we've been talking about exponential functions, and we want to know what their inverse functions are. The inverse function for the exponential functions are the log functions. In this video, we're going to talk about the inverse functions for trig functions, and those are going to be inverse trig functions. Okay, the name's not great, but at least you'll be able to connect them. This one, we're going to be talking about inverse trig functions. And again, the example of this is that inverse functions allow us to undo functions. Or in other words, they allow us to solve certain types of problems. For an example, if I had the problem, what is theta for sine of theta equals a half? Well, we know from when we talked about trig functions that there was a table that gave us the value. So, and the value was theta equals pi over 6, right? And we can look at circle, and we've got the angle here, the angle is pi over 6, and the values there, the x value was square root of 3 over 2, and the y value is 1/2, and this represents the x value, the first coordinate, the square root of 3 over 2 represents the cosine of pi over 6, and the second value, the 1/2, equals the sine of pi over 6. In other words, we have the sine pi over 6 equals a half. We learned that earlier, but what we haven't been able to do up to this point is what is theta for sine of theta equaling 4. This is where we're going to be able to use inverse operation or inverse functions in order to be able to solve this problem. So that's going to be kind of the goal of what we're going to be talking about. The first thing is, let's start with an example of f of x equals sine x, or trig function. And what does the graph of that look like? It's a wave. It looks like a wave. The highest y value it gets is a 1. The lowest y value it gets is a -1. In the last video, we talked about, in order to have an inverse function, the function has to be 1-to-1. To determine if a function is 1-to-1 is to look at the graph and do the horizontal line test. If I do a horizontal line test, the sine function fails terribly because it intersects here, 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 and here. That's more than once. Okay, it can only intersect it once. So we talked last time, how can you fix this issue? And you can fix it if we restrict the domain. Now, there's lots of ways we could restrict the domain. The way that is commonly done is we'll restrict it from going from here, which is -pi/2, up to here, x equals pi/2. So there's going to be a restriction. So our graph now is going to look like this: x is pi/2, x is -pi/2. And if I do the horizontal line test on that, we see that it is 1-to-1. So now I can find an inverse function for it. We're going to say f of x equals sine x on the interval from -pi/2, pi/2. Then the inverse function of this is going to be written as sine with a -1 there of x. Or sometimes people write it like this: the inverse function is arc sine of x. Either one is right. These are the inverse functions of f of x equals sine x. Make sure you understand too that -1 does not mean 1/sine x. It means inverse function. Okay, so let's do an example here. So what is the inverse sine of 1/2? So what does this mean? Remember last time when we talked about inverse functions, that what goes in the domain becomes, for the function, becomes the output for the inverse function, and what the output for the function becomes the input for the inverse function. So in other words, sine of -1/2, inverse sine of 1/2 equaling y is going to be equivalent to saying the sine of y equals a half. So we have this half goes there, this y. Inverse sine of a half equals y is the same thing as saying sine of y equals a half. So what does this tell us? So this tells us that the inverse sine of a half is an angle. It's the angle y. So we're going to be answering the question in this problem: what angle y gives the sine of y equals a half? Well, the answer to that is y equals pi/6, because the sine of pi/6 equals a half, which we talked about earlier up here. This is where we talked about that up there. And that was something we memorized in the chart when we talked about trig functions. That means the inverse sine of a half equals pi/6. Again, you have this change here, a half here, a half here, and pi/6 there, pi/6 there. So that was the inverse sine function, or the arc sine function. So we have all these inverse trig functions. So we have inverse sine of x. Again, we had to restrict it from the interval -pi/2 to pi/2. When we talk about the inverse cosine function, or also known as the arc cosine of x, same thing. We have to restrict it because it also is like a sine function, a wave function like this. Now, we can't restrict it on the same domain here, because if I look at my cosine function, it looks like this. Here's the wave. And if I did pi/2, I did pi/2 to pi/2, it's not going to be a -pi/2 to +pi/2. It's not going to be 1-to-1 on there. Okay, it looks kind of like an upside down parabola. So instead, we have to pick a different domain value, and we're going to pick these values here. We're not going to do that, but we're going to do 0, pi. And on that interval, cosine is 1 to 1. So we're going to do, for the cosine, inverse cosine, we're going to do 0 to pi. And then the last one that we'll talk about is the inverse trig function, inverse tangent function, okay, which also can be written as arctan of x. And we have to restrict that domain also. And that one we can go ahead and do negative pi over 2 to pi over 2. So let's look at another example in computing these inverse trig functions. So what is the value of the arc cosine of 1 over square root of 2? There we go, solution there. Arc cosine, again, is the same thing as the inverse cosine. We're going to look at that. The inverse cosine of 1 over square root of 2, we're going to say that equals y. And now we're going to compare that to the cosine. What goes here has to go here, and what is here has to go here. So we're going to end up with a y here and 1 over square root of 2. So you note that inverse cosine of 1 over square root of 2 equals an angle, because when we put that in there, we have cosine of y, and y is the angle, and that's what the value of inverse cosine of 1 over square root of 2 is. We want to answer the question, what angle y gives cosine of y equals 1 over square root of 2? Some of you may say, well, that wasn't one we memorized. Well, 1 over square root of 2 is, if I multiply square root of 2 over square root of 2, it's the same thing as square root of 2 over 2. And that is one you memorized. So cosine of pi over 4 equals square root of 2 over 2. And that's because if I look at the circle and I do an angle here of pi over 4, then I've got square root of 2, square root of 2, and that first term here is equal to the cosine of pi over 4. So cosine of pi over 4 is square root of 2 over 2. So what does that tell me then? Arc cosine of 1 over square root of 2 equals pi over 6. Now notice, some of you may say, well, wait a minute, cosine of negative pi over 6 also equals 1 over square root of 2. So why isn't the arc cosine of 1 over square root of 2 equal to negative pi over 6? That's because of cosine. Remember, we had to restrict the domain in order to make it 1 to 1 to 0 to pi. And pi over 6 is in 0 to pi, but negative pi over 6 is not in 0 to pi. So that's why the arc cosine of 1 over square root of 2 just equals pi over 6. Okay, let's do one more example here. Let's simplify the following. Suppose I have the sine of the inverse cosine of 1 over x. All right, so you may think, whoa, wait a minute, this is like we're combining things together, makes things really complicated. It is, but let's take it one step at a time. So let's start with the inverse cosine of 1 over x, and let's call it something. We'll call it y, just like we have been doing on these other ones. So this means the cosine of y equals 1 over x. So again, as we've said earlier, when I do inverse trig functions of some value, they're going to equal an angle. So I've got the cosine of y equals 1 over x. That is saying what angle y gives me the cosine of y equals 1 over x. So this is saying what angle y gives cosine of y equals 1 over x. 1 over x is not one of these numbers that we memorize. So what we're going to do, in fact, we have a variable in there. We have a 1 over x. So we're going to make a right triangle. And what am I going to let my angle be? Well, the angle is y as in the letter y. So this is going to be the angle. And what else do we know about right triangles? Well, if that angle is y, this side is known as the adjacent, this is known as the opposite, and this is known as the hypotenuse. And we'll remember that the cosine of the angle is the adjacent side over the hypotenuse side. And in this case, that is 1 over x from here. So the adjacent over the hypotenuse is 1 over x. So I can make my right triangle again, draw in my angle y, and I'm going to know that I'm going to have an adjacent side equivalent to 1 and the hypotenuse equivalent to x. Again, the ratio, it means the ratio of these sides is 1 over x. They could be different values, but it doesn't matter because we're going to have this work for every side here by using the Pythagorean theorem. And the Pythagorean theorem here is going to tell us that if I call this side b, the unknown side, then I'm going to have 1 squared plus b squared equals x squared. And we want to figure out what b is. So to do that, we'll solve for b. So I'm going to get b squared equals x squared minus 1, or b equals the square root of x squared minus 1. And so now I have my right triangle, and it looks like this. My angle y here, and I have the sides 1x and square root of x minus 1. All right, so now we can go back and solve the original problem. So remember, the original problem was the sine of the inverse sine of 1 over x. We said we let inverse cosine of 1 over x equal to be y. So the sine of inverse cosine 1 over x is going to equal the sine of y. This, and put it in here to give this. And now what is the sine of y? Sine is going to be opposite over hypotenuse. And we're going to look up here. There's the opposite and there's the hypotenuse. So we're going to get sine of y equals the opposite, which is square root of x squared minus 1 over x. So then we end up with the final thing that the sine of the inverse cosine of 1 over x equals square root of x squared minus 1 over x. And that gives us the answer. All right. Well, hopefully that will help you with your homework and understanding these inverse trig functions.